Let us solve this question using the properties of circles and triangles. Now, what is the situation given here? We have a pulley. Along its rim is an elastic belt. Now we are pulling this elastic belt till it reaches a point P in such a way that the distance of P from O, the center of the circle, is 10 centimeter. Now the radius of this pulley is 5 centimeters. Now what do you have to find? You have to find the length of the belt which is still in contact, not the one which we pulled. If this is A and if suppose this point is B, we have to find this part of the circumference which is still attached to the pulley, not the one that we pulled away. That is one thing you have to find. The next thing you have to find is the area of this shaded region. Now, what is this angle? We can see that PA is the tangent from the external point P. So at the point of contact, PA and OP will be perpendicular, or in other words, this will be a 90 degrees. Now this is all you need to know, that this angle is a right angle. Then what will follow? It will follow that this is 60 degrees, this is 30 degrees, and this side here is 5√3. Now we are not pulling rabbits out of the hat. How did we deduce this whole thing? All we needed was a right triangle and just two measurements. We just needed a 5 here and a 10 here. The rest of all we can deduce. Why is that? Now in the basics of trigonometry, we learned two special triangles. One is 30, 60, 90 degrees with its sides in the ratio 1√3 and 2. And the second special triangle with the angles 45, 45, 90, and the ratio of the sides with 1:1:√2. Now we are dealing here with this. Here we will concentrate on this type of triangle. Suppose your triangle looks like this. Randomly I will take this one as 30 degrees. Then the third angle of the triangle will be 60 degrees. Opposite to the smallest angle will be the smallest side. The second smallest angle opposite to it will be the second smallest side. √3 is just 1.7 something. So this will come here. The greatest angle opposite to it, the greatest side. Now this is the ratio. Why is this important? Usually when you deal with a triangle, you have to find different ways to find each of its sides and then each of its angles. But in such a triangle, they are all connected. You just need one angle and one side, or you just need two sides. That is enough. Everything else just follows. Now, what is the situation that we have here? We do not know anything about this side or this angle or this angle. Randomly take this as theta. Then what do you have sine theta as? It is opposite side by hypotenuse, which is equal to 1/2. Now the sine of which angle is half? It is sine 30, which means what? This theta here is 30, which means its opposite side is what? 60. And what is this side? Applying the Pythagoras theorem, you will get 10 square minus 5 square, which is 100 minus 25, which is 75. But 75 is not the answer here. It is the square root of 75, which is 5√3. Now you see how we got it? All we started with is just a 5 and a 10. Now you can try this in any other way. Suppose randomly you have a 7 here and a 7√3 here. Then just by looking at it, you should know that this side here, this is 1:√3. Here it will be 1:2. Therefore you should get 14 here. Opposite to 7, the smallest angle will be 30. Opposite to this, the greatest side, of course this is 90. Now the second smallest side, opposite it, will be 60, which is the second smallest angle. So please remember this scenario. All you need is just two sides like what you have, but then to start with you need a right triangle. Don't forget that we need a right triangle to apply all of this. So all you need is just two sides, or what do you need? One angle and one side. Even that way it will work. Suppose this is 30 degrees and you just know that this here is 10. You do not know anything about any other sides or angles, you do not know. Then what is sine 30? Sine 30 would be half. But what is it? Opposite side by hypotenuse. Now you don't know what the hypotenuse is. Cross multiply, you will see that this is 20, and what will you get here? It will be 10 root 3. So just by looking at it, you must be able to deduce all the other information that we just now studied. Let's move on from our preliminaries and start solving our question. We have to find the area of the shaded region. How do we find that out? Find the area of the triangle AOP, this triangle. From that, subtract the area of this sector. I will name it 1. Subtract the area of the sector AOX here. Then you get just one part, the part which is above OP. Then to this answer, multiply with the 2, you get your required result. So shall we start? First we will find out what is the area of the triangle AOP, that is half into base into altitude. Now you know what OA is, it is 5. What is AP? AP is the side of a right triangle, right? It is the square of the hypotenuse minus square of the other side, which is 25. 5 square, that is root 75, which is 5 root 3. But then we already know that, right? So let us substitute the values. What do you get? You get half into 5 into 5 root 3, which means 25 by 2 root 3. Now, what about the area of OAX? What all information do we need for that? We need to know what is the angle that it makes, and we need to know the radius. We already know the radius, it is 5. See here, this is 5 and this is 5. What about theta? How do you find theta? Cos theta. Now you know this, right? Cos theta is what? Adjacent side by hypotenuse, which is what? 5 by 10, which is what? 1 by 2. Now the cos value of which angle is half? It is cos 60, remember? So which means what? Your theta is actually 60 degrees. Now this much here we have found out to be 60 degrees. Substituting the values, you get again r square is 25. So there, this is 60, 60 and a 360 gets cancelled, and you get 25 pi by 6. So our required area is what? The first equation minus the second equation, but remember that is only the part above OP. You have to still do a into 2 because you want the whole region, right? There, this is the area. Now this is the area of AXP. Multiply into 2, you get this, or in other words, you get the required area. Now we also have to find the length of the elastic still attached to the pulley, or in other words, we have to find this length. Now what is the formula for that? It is 2 pi r by 360 into theta, where theta is the angle that it makes, that is this angle, not this one, not 120, but this angle. What is it? It is 360 minus 120, which is what? 240 by 360. And what is r? R is 5, and this is the answer that we are looking for.